So we'll start
Good
our
evening.
session today.
Yeah, good evening, sir.
Yeah, good evening. So I hope that all of you have downloaded AP Info. So
Yes,
anyone who has yet not downloaded AP Info?
downloaded, sir.
Yeah. So those who have not done may do it, and we'll see that at some point of time today itself. So, and I have said two, three files also for central tendency, etc. So we talk of few problems and then how to apply a statistical test in that condition, and then we'll switch over to the mean, median mode, etc. Then we shall talk something about central tendency. And at the end of the day, we should know something about p-value and also about how to use the AP info to find out that p-value. So first, mm, uh, anyone can share any one problem where we shall be using our statistical test and we'll be doing some epidemiological investigation. Dhruv, can you tell me something about problem? Any one problem?
Hello, sir. Hello, sir.
Yes. Okay. Can you tell me something about any problem?
Sir, today is my first session, so I am currently not know about
No,
the.
even first session, you just tell me where do you work?
Sir, I am in Jimar Sola Medical College in second year.
So you have the various problem in hostel, right? For example, you have a water problem, yes or no?
Sir, actually, I am a localite. So,
Okay, so you don't know what is it. So in localite also you should have some problem like URI or dengue. You must be looking around.
yes, sir. I have a dengue last year.
You yourself had.
Yes, sir.
Yeah, so like let's say dengue is a problem. So if you want to find out in Ahmedabad city, there is a let's say 70 lakh population, and you want to find out then last 1 month how many people would have suffered from dengue. If suppose this is our the problem where we want to do the epidemiological study as well as we want to apply some statistical test, right? So the question is the population, let's say Ahmedabad is 70 lakh population. We want to find out the how many people in Ahmedabad suffered from dengue in last 1 month. And dengue we define two ways. One is symptomatological, another is the lab diagnosis. Two things we can take together. So, so if we want to take, let's say, the whole population out of that, if you want to search, we need to survey 70 lakh people and find out that how many suffered. So it will take a lot of manpower and etc. etc. So we can take a sample of it, and the question would be how much sample you would require in a whole Ahmedabad city to find out that how many people suffer from it. So for that we have AP Info software where there is something like StatCalc is available, and that you can use to find out the sample size. We'll not go into detail of it, but then at least we'll see where it is located. So I will share the screen now. Can you see this AP info?
Yes, yes,
So
Yes, sir.
here is a stat calc where if you want to do a population survey, then you have a population survey over here, right? And you write down your population size is 70 lakh. And then expected frequency. Do you think that 50% of the people might be suffering from dengue in last 1 month? Might be suffering, must have suffered or might have suffered from dengue 50% population? What do you think? Or 10% approximate idea? So when you don't have any idea, you go for 50%, that will give the maximum sample size which is required. But in this case, we fairly know that out of 10 house might be one or two case may be there. So we can take a 10%, not more than 10% people might be suffering. Now, when you talk based on a sample about the population, I repeat, when you talk about population based on a sample, there will be some error. Yes or no? Just unmute yourself and tell me. When we will talk about population based on a sample, will there be error? Yes or no?
Yes, sir. We discussed.
Yes.
Yes.
And that error is known as sampling error. And that sampling error, if you want to standardize, it is known as standard error. Now here, the computer is asking us accepted margin of error. That means if you get the answer, let's say 10%, how much difference you would like to have? 5 to 15% or 9 to 11%, 1% to how much error would you like to accept, which will be there because of sample. So if a commissioner is very strict, he or she can tell you that 9 to 11%. If a liberal person is there, like a politician, he may say 5-10% idhar chalega. Then he may tell you 5%. So let's say if you go with the 5%, what will happen? So you can see the sample size over here. Can you see this? This table, can you see this?
Yes, sir.
70 lakh is the population, 10% is the expected frequency, 5% is the allowable margin. Design effect is 1 and cluster is 1. Now, design effect in this case, directly from Ahmedabad, if you're taking, then there will be only 1. But if you are divide the Ahmedabad into various wards, for example, Paldi, Vasna, etc., and then you take from each ward, you take the proportional sample, then because you have done a stratification, there will be design effect. So if you are going to take 2 design effect, the sample size will increase. If it is a 1, sample size is only this much. And in this confidence level, usually we take 95%. So you can see the 138. But the moment instead of 5% error, if I go for 1% error, you look at the sample size increase, 3,456. 3,400. You need to have something like the 3.5 thousand, right? And if you take away design effect, you will see that the sample size will increase. See, it is 6,900. Can you see this figure, 6,900 in your screen?
Yes, sir.
Yes, sir.
So now if I take a 20% expected frequency and see what has happened, sample size increases. Because if I go for 50%, still sample size will be increased because 50% means suffering, non-suffering, and based on that, you want to talk about that. If it is an equal number, then it will be difficult to talk about the population based on a sample because hardly there is any differentiation. So, if I say design effect is 1, directly taking random samples from, even if it is a systematic random sample from electoral list of whole Ahmedabad, it will less. So now if you want to do population survey, based on a sample, want to talk about the population, I think all of you will be able to find out the sample size. Now, if I increase the cluster, what will happen? 2 clusters, like say 3 clusters, I say 4 clusters. See, right? So cluster size, it is talking about cluster size, but the total sample size is written over here. If it is only 1, then this both figure, cluster size and total sample remains the same. If I say I want to take a 5 cluster, then in each cluster, how much you will be taking? 1918. So I think this is a very simple tool in which you can find out the sample size easily. And we can come back to this again whenever there is difficulty. But I think you should note down that today you can find out sample survey if you want to find out how many dengue cases total in Ahmedabad. And depending on your accuracy. And I think that even if you go for, let's say, 2%, and here 1 cluster, and then here 10%, practically this will be the 864. So approximately 1,000 sample if you take from whole Ahmedabad, that is good enough. But practically directly taking from all Ahmedabad is very difficult, and that's why it is better that you take 50 clusters from Ahmedabad, have a 2 design effect, and this will be much better idea, taking a sample of once the 35 from each. Approximately, you can say if you are missing something, 40 from each. If you take a sample of 2,000 from whole Ahmedabad, will tell you how many people are suffering in Ahmedabad. Similarly, how many people are happy now? How many the houses are having the waste segregation, etc. So this is how we can measure. How determine the cluster size and design effect? See, the cluster size means usually the ideal is 40 cluster and in 6% in each cluster. But the 6% or how many person that they let the computer decide. Usually, initially we used to take 30 cluster and 7% in each cluster. But nowadays, it is much better to take a 40 cluster. That will be better. And that's why, and the moment you take a cluster systematically, systematic random sample out of the particular number of the wards, and from which ward your cluster will fall, if you want to find out that, then there is another tactic of cumulative population that we'll see at a later date. You should write down that you need to know that from where you need to take cluster. Loss quality assessment sampling technique also will learn in that the same thing is done. You have a list of the areas and then cumulative. And from that you find out. We have an Excel file ready for that. And the acceptable margin usually depends on how accuracy you want to have. So this will be giving you the sample size. Right? And if you want to be more accurate, then you need to take more sample size. Any other question? So let me move.
Sir, what about the design effect, sir? How is that determined?
Design effect, see, the moment you, usually when we do the sample size, what computer assumes that directly from the population, you are taking simple random or systematic random. Directly you are taking from the population. But when you divide the population in subgroups, at that time, the design effect takes place and we take a double of it. Suppose you again do the third factor. I will give you an example. In the whole country, you are dividing into states. And further, the states you are dividing into districts. And then you are taking from that district random effect. Then the first, second, and third, instead of design effect 1, you are taking 2 because of taking a states. But now you are taking the districts within the state. So your design effect will be 3. This is how you multiply so that you will get the right choice. Because if you look at the statistical funda behind that, when you take sample directly, each individual within the population has an equal chance of being selected. But while you divide into the various strata, then we can't say that each individual has an equal chance of being selected. And for that purpose, we need to have a larger sample so that it represents the population. Ultimately, we need to talk about the population. So we should have a sufficient sample size so that we can talk about population. Any other question?
Sir, how to know this expected frequency, sir?
That you should go through the literature. In literature, if you don't have any literature, go for 50%, 50%. But at least your gut feeling will tell you that Ahmedabad में 70 lakh में 35 lakh population are not suffering from dengue, right?
Yes, sir.
So, yes, you can directly take a telephone directory, Tata Yellow Pages or maybe BSNL directory, do a randomly 100 telephone calls, then you will come to know at
Okay.
least that whether the people are suffering from dengue or 10% or 20 or 30% grossly, you can find out. So it
Okay.
is better to have a higher size of sample size, and for that person go for 50%. And the highest number you will get.
Okay,
The
sir.
more the question you ask, more the clarity you will have. So I will close this because there are other things also, but we go the problem base. Now, there is something like classic in which you can do the analysis of the data. This NAP info will look like this. The first step is read the file. So I'm reading a file. It is located somewhere. You should know where your file is located. It's a part of a AP Info 7 projects file. Here the project means in a single project there can be multiple database files which could be related to each other. And here I'm just giving an example of Oswego. And this is a very interesting example and difficult for analysis. So you will see that the number of records selected are 75. Can you see the figure of 75 over here?
Yes.
So you can look at the data like this, how it looks like. If you use the list command, it will be looking like Excel file. Here is a name, age, sex. So illness, yes or no, that means 0 and 1. Backed, spinach, mashed potato. People are taking a lot of foods. No? There was a party because of birthday party, and people took some water, some took fruit salad, some took chocolate, and etc. Some took vanilla ice cream. So this is the data of 75 individuals. The same data you can have in Excel file also. Right? The data is already done. Even if you have Excel data, the computer will be able to analyze. So there are 75 people. And out of that, we want to find out frequency. So 3 commands we'll be looking at: frequency, tables, and means. The read command already demonstrated. You read the file, whichever you want. And I will tell you that till the Wednesday, you should start using this, the AP info. And all this sample, we work on the sample file, which is already given. The next time we will be using the Excel file. So in frequency, if you use a star and give OK, it will analyze all the data and frequency will be given to you. This is how the frequency will look like. All the frequency age-wise, right? Then the illness, you can see that 46% are sick out of 75. And we need to find out why this is a problem. Is it because of water or is it because of chocolate or what are the things? So we need to find out that. And the people backed item was taken by 46% and the 43 people took spinach, mashed potato by 37 like this, right? So now let's go for the table command. And if you don't want frequency of, if you want only the frequency of, for example, coffee, how many people took coffee or not, then you can take only for the coffee. So before you do the analysis, you should take a frequency, just keep it print out with you, and then start doing the analysis between different things. And suppose you have 20 variables in your file, and you want to compare the 20 variables with 20 variables, permutation, combination. How many tables you will find like this? I will give examples so that you can know whether the illness occurred because of the coffee or not. If you do this, then we'll have the p-value. P-value is 0.9. That means if p-value is more than 0.05, no statistically significant difference. That we'll see based on the curve. But here it compares that coffee is not having much effect on the illness. Rather, both the things, no, whether coffee taken or not, there is almost 61% are sick in both the group. So no much difference. This is a table, coffee versus illness. If I take permutation combination, 20 variables between various, then how many such tables you expect we can have? Any answer? 20 variables compare with other 20, just like coffee versus illness, vanilla versus illness, vanilla versus coffee, gender versus coffee, like this. How many tables will have? Any idea?
400 tables, sir.
400. But then there are the same thing will be there, 20. So 400 minus 20, because same thing, coffee versus coffee. We can't call it stable. So 400 minus 20. So what is that? 380. But then when you say illness versus coffee or coffee versus illness, both are the same. So you will have a mirror image. So 380 divided by 2. So 190 tables you will have. So even if you have 20 variables, in essence, you can go for analysis in 190 various permutation combinations you will have. But I'm talking only 2 by 2 table. But if there is a, let's say, 3 by 2, 4 by 2, or multiple things, then you can have more things also. So there is something like confounding variable, which affects the exposure and outcome both. Such confounding variable, you need to neutralize. That technique also is given by the software. And in this case, if you want to find out the difference in mean age of age, is there any age difference in the illness, sick and healthy person? So will give us the mean, the variance, standard deviation. The standard deviation square is a variance. And the answer, the question asked to you could be, what do you mean by standard deviation? And for that, you need to answer what do you mean by mean of the deviations. That means what do you mean by the deviation? That means each observation find out distance in respect to the mean. That is a one deviation. Second deviation. So if you make all the deviations total, that will give you the total deviations. You divide by the total number of the deviations, it will give mean of the deviation. But in giving a mean of the deviation, minus and plus sign will be nullifying each other. So to remove that minus plus sign, we make a square of each deviations. And because we make a square of each deviation, and then divided by number of deviation, take a root of it, that will give you standard deviation. And when you take a standard deviation, the question is why it is known as standard? Because it's like a kilogram or like a meter. It's like that standard. Always plus, if you take a mean plus minus 2 standard deviation, it will cover around 95% observations. So to find out the outliers, we find the standard deviation, mean plus minus 2 standard deviation, 95% are covered. If something is beyond that, likelihood within the group is less than 5%. And when we use the word p-value, this is a probability of event occurring by chance. So in this case, if those who are sick, the age is around 39 years is the mean, 21 is the standard deviation. For time being, let's say 40 years is the mean, 20 is the standard deviation. Then plus minus 2 standard deviation will be almost 0 to 80 years. So if there is someone who 85 years or 89 years is beyond this the 95% limit. But then in this case, 39 and 32, is this difference significant? So we go for the p-value, and this p is 0.21. Although it looks significant, actually it is not. So we'll say that although there looks to be difference, age is not the significant factor in causation of the illness. And there is another variable is the logistic regression, in which outcome variable is illness. It is an illness. And in this case, let's take as a cake, or let's take as a chocolate, then the coffee, then we take a rose, then gender, then do you like vanilla? Take a vanilla also, and milk, and you take this variable, yes, no variables, and try to compare. So it gives a whole comparison out of this many things, what could be the positive factor. So here, p-value, if it is less than 0.05, in two cases, in vanilla is less than 0.000, and in the gender it is 0.04. So two are the factors which are most likely to, as a causative factor or as a exposure factor, which are contributing to the sickness. Vanilla is strongly associated almost 32 times, not exactly 32 times, and females are more affected than the male. So this is how you apply your statistics to find out who is affected. While you go for the constant, coefficient, etc., that will be useful when you go for the regression equation, that you want to find out y is equal to ax plus b. So b is the constant, right? And the a is coefficient. This is how you can find out. So this is not our cup of tea, but this you should know that Epidemiology has this power to do. The analysis is the multivariate it can do it. So this Epidemiology will be using at least 5 times during our various cases, and you should use it. Also, you should try to take a help in Epidemiology, and it will go for the internet and find out whatever you want to find out. There are online modules also available for the Epidemiology, but the way you start using it, you will come to know about it. So all of you should at least use Epidemiology, and then we'll be switching over to any other question. So here, the whole game of statistics is basically the difference between statistics and mathematics. Mathematics is 1 plus 1 is equal to 2. While statistics is if some value is near to 1, you add the value near to the 1, then it will not be 2, but it will be near to 2. So this is how it is an approximation. It's basically the finding out the probability. And to understand probability in easier manner, the percentage is out of 100. See, 5 out of 100, that is 5%. Percent, cent is 100. But 5 out of 100 in probability, it is known as 0.05 out of 1. Probability is always 1. Whether it's a 10,000, 1 lakh population, you say 1 lakh is equal to 1 and then calculate the probability accordingly. Like percent you calculate out of 100, in probability you find out of 1. That is the only major change. So first, in statistics, if an event is taking place, there are 2 events, 3 events, 4. What is the likelihood that that event will take place? In dengue, you have, let's say, the 1,000 population, and you want to find out who will suffer and who will not suffer. That you want to find out the prediction. You want to become a Jyotish, right? You want to forecast. Then the statistics will help you, whether the person will develop the dengue or not. Statistics will not tell you that this person will develop or not develop, but so what is the probability of that this person will develop the dengue? That it can calculate based on the data which you give. Now, the first slide which we would like to see the measure of dispersion, because from that we'll have a little bit about the p-value. Once you know about the p-value, once you know about the Epinfo software, I think most of the thing is covered. So you can ask any question in between also. So can you see this slide?
Yes, sir.
Yes, sir. Visible, sir.
We want to talk about measure of dispersion. Now the word, till now you might be talking about the mean. We want to compare Ahmedabad and Baroda. What is the mean age of the population? So the age, 70 lakh people and 30 lakh people, if you start directly compare the age, it is very difficult. So what do you do? Mean age of the Baroda, mean age of the Ahmedabad people. That is true. But then mean could be same. But the dispersion, the distribution around the mean could be different. So we need to take the distribution also. This slide will tell you why you need to have the dispersion or the deviations or the distribution around the mean. I hope that now you are clear that at the same mean there could be this difference in the observation. So comparing mean alone is not sufficient. That's why you need to compare something other than mean. So other than, if you want to, along with the mean, you talk range. What is the minimum? What is maximum? Can you also talk variance? That is the square of the standard deviation. then the standard deviation, and then coefficient of variation. So it's in terms of the mean. What is the value of standard deviation? Suppose mean is 100 in both the case. Let's say the money is spent for the food for a day, 1 day. So in Baroda and Ahmedabad, 100 rupees people are spending mean expenditure per day for the food. But then standard deviation in Ahmedabad is 50 and in Baroda it is 10. What does it mean? That the coefficient of variation, the variation in Ahmedabad, 50 against the 100 is too much, while 10 against 100 is less. So the standard deviation and mean alone are not sufficient. You need to find out how much is the coefficient of variation, how much the variation in terms of the mean. So that also we can find out coefficient of variation. Interquartile range, that is less than 25%, 25 to 50%, 50 to 75%, like that. If some range is too much, then you can say that because of that it affects the mean. Let's say the Mukesh Ambani is staying in the Baroda, right? Then he can change the mean of the whole Baroda because of his lot of expenditure, a lot of income. So that's why at that time quartile range will help you that he is between 75 to 100% and taking too much like that. So by making various groups also, you can find out which group is giving a lot of emphasis or affects the mean. So range, already we talked minimum and maximum.
Difference.
The standard deviation, most commonly used. And whenever we compare the two data set, we not only compare the mean, but we compare the standard deviation also. And now I had provided you the Z table. Now the Z table is useful to find out the number of population in a certain the range. Suppose we have 50 kg is a mean weight. We have total 1000 population. And 10 is a standard deviation. 50 kg is the mean weight in kg, 10 is a standard deviation, and total 1000 population. My simple question, how many people lie between 40 kg to 60 kg? Any answer?
All the people.
Huh?
All the people.
No, not all the way. Because
It is for standard deviation between plus one minus one.
minus one standard deviation will cover around 68% population.
Correct.
So the mean, so between 40 to 60 kg, there will be 680 people between that range. So if you want to do something for the malnourished people, for example, the question could be how many people lie below 30 kg. So 2.5%. So 2.5% of 1000 will be 25. So you need to do the expenditure for 25 people. So these figures you can find out from Z table. A particular range you want to find out how many people between these two. So Z tables gives you area under the curve. Total area under the curve is 1. So we'll see that how we can actually use this. And almost at many places will be require Z, whether it's a standard of mean or standard of difference between two mean. At that time we require standard deviation. So before you take a root, there is already a square of standard deviation which is known as variance. This diagram shows you that the total area under the curve is 1. Even if you use these words or this sentence 10 times, just bombard your mind with this, flush your mind that total area under the curve is 1. Or in terms of percentage, 100%. Suppose total population under your study is 10,000, means 10,000 is equal to 100% is equal to 1 as far as the probability is concerned. So when we say that this yellow area is standard deviation plus the mean plus minus 1 standard deviation. The blue area, if you cover that, then the mean plus minus 2 standard deviation. And for 1 standard deviation and 2 standard, this is 13.59. Here it is 13.59. If you take a area between 1 standard deviation, 2 standard deviation. But if it is beyond 2 standard deviation, when we say that mean plus minus 2 standard deviation, it covers 95%. So how do we find a Z? Z is equal to, you find out the x minus x bar, that is the distance divided by SD. That will give you the how far the observation is there from the mean. So this actually 2.14%, here 2.1%, but for time being, let's say it's about 2.5%. So together, this and this together is the, let's say 5%. 5% means in probably 0.05. So P is, you should write down somewhere, P is nothing but a probability of event occurring by chance. Now, here you should take a pause. For ever in your life, you need to remember that P is a probability of event occurring by chance. So if a person belongs to this group, it is between this range. If it is away from this range, it is outside the group. Less than this, outside the group. So if it is somewhere here, the likelihood that belongs to this group is less than 5% or less than 0.05. That means this chance distribution, it is beyond that. It is less likely that it is by chance. This we can also tell as a chance distribution. So if it is within this, it will say it is by chance. It outside this, we say not by chance. Again, if it is within this, we say by chance. If it is outside this, outside means beyond 95%, so is less than 5%. We say that not by chance or significant. This is why we say that when Z is more than 2, what is Z? It measures the distance between mean and the observation. If it is more than 2 standard deviation away, that means Z is more than 2. That means less likely that the observation is belonging to this group. So that's why we say that Z is equal to x minus x bar upon SD. So if the distance is more than 2 standard deviation away, we'll say that it is less than 5% chance. So probability of event occurring by chance is less than 5% or less than 0.05. So when P is less than 0.05, that means observation is far away and less likely that it belongs to the group, less likely that differences occur by chance, and we say that it is significant. So we write that if P is less than 0.05, we can say that the observation what is there is usually not by chance. There is some reason behind that. So that is the standard deviation, mean, and p-value. To be specific, 68.26%, but I usually use the 68. I usually use 95%, not 45%. For the purpose of understanding, we can remember that much only. Otherwise, the Z table is going to give you the further details. If someone wants to be much sure about, person says that 95% confidence is not enough for me. I'm going to go for 99.7% confidence. Confidence limit means when you give your statement, the confidence means the likelihood that your statement is right is 99.7% correct. Some of the few percentage you may not be correct. That's why it is also known as confidence interval. this SDF ungrouped data and group data, etc. are there, but we just this SD and everything is going to be given by the computer. So you need not go in that formula, but only thing remember why it is n minus 1 in a smaller case, because suppose this 10% are attending the course. If you want to go in somebody's house, one person will be in the center, people go to that place. That deviation almost nil, because at least the one observation will be near to the mean, and that person did not the travel much. So that deviation is almost nil, and that's why we are doing n minus 1. Because if 10 people are there, deviation will be only around 9, because one will be near to the mean. And that's why we do n minus 1 to find out the average of the deviations. But why we take a square? Because we want to remove the sign of minus and plus. And then why we do the square root? Because ultimately we want to go the tangible figure. Because we had a square root, we are doing the root also. This is the formula for standard deviation. This we need not go for the group data, etc.
So that can be used only when your sample is less than 30 or so much.
So even if your sample is, let's say, 100, you can 100 minus 1. That will give you much better result.
Okay.
But when the figure goes beyond 30, whether you do minus 1 or not, it doesn't make much difference. That's why we are taking n. Otherwise, ideally, even if your sample size is 1 lakh, you should do 1 lakh minus 1. That is ideal. But because it doesn't make much difference to the calculation, we are not doing. Because logically, if you see, let's say 50 individuals, only 49 people will have to move, because one person will be almost near to the center, right? And that's why you do at least minus 1. So that is the idea. So when you're confused whether to do minus 1 or not, at that time you do it. No problem.
Okay. Yes.
So does all the variables come in the same frequency, sir? Is it applicable to all the variables?
In your case, variables, suppose you are letting height, weight, whatever you take, right? Any measurement, body measurement you are taking, if that follows the normal distribution means that in between there will be more people will be there, and at the end there will be less people. If you go for that kind of distribution, then it will follow that. There is something like binomial distribution. For example, when there is accidents taking place, so at the younger age and the older age, that is a binomial distribution, the bimodal distribution, multimodal. So unimodal distribution is there. At that time, normal distribution will be there, and you can apply all those things. And most of the time, height, weight, if you look at the hemoglobin, etc., you will have inverted U-shaped curve.
Okay, sir.
So there is a coefficient of variance. People are not using sometimes, but ideally, if you want to compare two population, you should need to find out how much is the standard deviation. If standard deviation compared to the mean is much more, that means in that population, heterogeneity is more, homogeneity is less. So to find out that also you need to have. For example, if you compare the Pakistan, for example, there will be the difference between the rich and poor will be much more than the India. Even, for example, some autocratic countries at that time, while in China, if you look at this standard deviation, will be lesser than even India, because the socialist country, so they will have almost the same level of income if you look at that. So SD and mean comparison will give you. I hope you have understood the concept of coefficient of variance.
Yes.
In terms of in this case, it says that for the height and weight. So in weight, there is it says that 10 is more and 5 is less. But then in terms of percentage, when you compare, weight is more variable compared to the height. Look at this table, right?
Yeah.
When we
Yes.
say 10 centimeter 5 kg, it clearly says height is more variable than the weight. But if you look at the in comparison to the mean, the weight is more varied among the group compared to the height. So the question is, the weight is more variable than the height, and height is more consistent. What is first 25%, then middle 25 like that. So we need not go for that. The file is already given to you. We'll switch over to the next. So here, I think you should have a now clear-cut concept of what do you mean by the Z, what do you mean by the p-value, and the standard deviation. And when we talk about the standard error, remember standard is nothing but one kind of sampling error. Sampling error, which is standardized by a particular formula that is known as standard error. But can anybody tell me, if I give a statement, the standard error is one kind of standard deviation, will you agree to that?
No.
If I use the word standard error is one kind of standard deviation, will you agree to that?
No, no.
Actually, it is.
It is
Standard error is nothing but one kind of standard deviation. But that we'll see the next lecture, why it is standard deviation. So
Okay.
that concept requires some time, because when we talk about the proportion, if we are talking about mean and we talk about the standard deviation and standard of mean or standard is okay. But when we talk about the proportion, at that time, how can we have a standard of proportion and standard of difference into proportion? How can there be the concept of standard deviation in the proportion? But then we'll clarify in next lecture. If you want to have a sound base in statistics, you should know about the standard deviation, standard error, the p-value, the z value, etc. Then you will be strong enough. Even if you know about standard, then you will know even how to calculate the sample size. Sample size will depend on how much standard error you would like to allow. So that is important. And then let's talk something about the same thing in a different perspective. Although sometimes if people ask you to talk about what do you mean by self-containers. So again, I talk about Ahmedabad. In Ahmedabad, if I, let's say the expenditure per capita expenditure in Ahmedabad, let's say actual one is 150 rupees per day per person, actual. Now, when you take a sample and talk about the population, it may turn out 170, someday it may turn out 130, etc. But when you take 10 or 20 or 30 sample, you will be going to 150, near to the 150. Again, you go for that another 10 or 20 sample. Again, take a mean of those samples. Again, it will go near to the 150. So the more the sample you go on taking, ultimately there will be tendency to go towards the center, the correct figure. That is the central tendency. There is a word mean, median, and mode.
Yes.
So mean alone may give the answer, may not give you answer. And that's why AP info gives you the mean, mode, median, all the three figures for you to calculate. And because you have AP info, try to read all the figures.
Mm.
Mean is an arithmetic mean.
Arithmetic.
Why? Formula we already know about the mean. We did not go for that right now. There's a weighted mean method also. But then There is something like median also, right? Median is a middle value. It totally divided into two groups, upper and middle. That's the median, middle value.
Mm.
Right? Middle value.
Mm.
And so we talk about the most frequently occurring value. You see, even you take a middle two and divide two, it's nothing much difficult. And the mode. Mode is the most frequently occurring value. Most people are having this much age or like that. This is a 4.9 is a mode. Here there is no mode. It is a 4.9. So when the data is given to you, you need to find out all the three things, mean, median, mode, if you want to compare the data. Now, just before I end this session, the gist is whenever you start taking one problem, where in which your question should have the characteristic variable like the caste, the religion, the gender, and you should have the quantitative variable like height, weight, etc., or per capita income. Then you will be able to use the AP info in a better way. And you should write down somewhere that P is probability of event occurring by chance. P is probability of event occurring by chance. And
Yes.
if that chance is less than 5%, that it is occurring by chance, that means there is some reason behind that and it is significant. That is how you should look at the P value. And so try to use the AP info and we'll be working on AP info again. And whenever you are having a problem, so how much sample you will be taking to talk about the population, think of that. And when you read the epidemiology, you should be talking about time, place, and person, where, who is affected, when it is affected, all those things. Okay. Ultimately, we want to find out the relationship between the variables, why it is occurring. And if you can play the game of why, just ask the question why 5 times to a particular problem. Next time, we should be taking that why and so what. If it's a malaria, why malaria? And those are factors will be there. Why those factors? Why those? If you go for 5 times, you will come out with a marvelous result. And if malaria, so what? What will happen because of malaria? But if the school absenteeism, more load in the healthcare system, etc., then again ask, so what? And then you will come to the various chain of the web of position and web of effect. And if you compare the upper and lower side, there are some few things that are common. And then positive cycle and negative cycle, you will be able to know it. And then based on statistical analysis, you will be able to find out where I should attack, where I should work upon, which is the factor where I should work, and how I should work for that. So that will be looking in the next few lectures. Any other question?
No.
Sagar, Rashmi, Dhruv, Alvin. The most important thing, your interaction and your homework is important.
Yeah.
So I expect at least you start working on one problem, try to do a pilot study, and then ultimately we'll go for the at least one study which all 10 of you can do at at your own place. Okay. Thank you.
Okay. Thank you.